Speaking of cassava and speaking of materials, we now move on to our third plenary, Materials Matter. Materials are the building blocks of design. For our third plenary on material design and innovation, our next speaker asserts that materials matter. Through his work, we investigate how crucial materials are in making smarter choices for today and beyond. He plays a key role in the expansion of Material ConneXion's technical knowledge base. His research directs the implementation of consulting projects and the selection of innovative, sustainable, and advanced materials to Material ConneXion's library. As the Executive Vice President of Research at Material ConneXion, the Chief Material Scientist at Sandow, he has helped hundreds of clients from Whirlpool and Adidas to BMW and Procter & Gamble develop or improve their products. A leading expert on sustainable materials, his insight has played an important role in creating a new generation of more sustainable products. Ladies and gentlemen, please welcome to the stage Dr. Andrew Dent.
Thanks very much. Is it on? Okay, good. I'm not sure how much carbon it took to get me here, but I'm glad I did. I'm excited to be here. I've been here for 3 or 4 days, and I've learned an awful lot. I'm excited about the sort of material research that's going on here, about the sort of innovations, and about the material use. So my job for the last 20 years has been to find innovative materials, sustainable materials, and help my clients implement those materials into their products. We do that for every kind of household brand, many of the consumer products that you're probably wearing or using today. The materials themselves come from all different industries, and the idea is for us to make sure that they're implementable, to understand their sustainability, and make sure that they work at the right sort of price point as well. So our clients come to us for those sorts of things. I do this through a materials library. So we have a materials library in New York City. We also have a number of them around the world. There's actually a small example over in the corner. You can see that it says Material ConneXion, so you can see the sort of samples that we have. Materials for design, for sustainability, and for innovation. We've been collecting these for the last 20 years. We have about 10,000. And the idea really is to take materials from all over the world, let's say it's from the Philippines, and then show them to the brands that might use them. We do this through physical samples and through our online database as well. We have these library locations around the world. This one's in New York. This next one's in North Carolina. We have them in other parts of Asia as well. So who are the brands that we help? So it's basically everybody who uses materials. The advantage with that, of course, is there's an awful lot of cross-pollination between different industries. You'd be surprised at how many different industries need one type of material. So in understanding what the needs are, let's say for automotive or for home appliances, we can then help other industries with the solutions that those industries are created. So as a group of designers, you of course are interested in how to use materials and what materials you can use. You're also always interested in what the consumer wants. Now, it's interesting working with these brands, you start to understand the difference between what the designer thinks is a good solution and what the consumer how they decide to make that choice. I got one interesting example. Okay, so in the US where I work, people buy mattresses, so they buy beds, okay? So you would have thought if a relatively large product such as a bed, you spend a fair amount of time researching and understanding its performance and how well it works for the job it's intended to do, to sleep on. Okay, so this is what actually happens when someone buys a mattress. Okay, so you go into the store, okay, so you look at all of the beds in the store and you decide, okay, well, initially, Americans buy by size. They like big things. So basically the highest bed is the one you immediately assume is going to be the best one. So you immediately go for the highest bed, which of course makes no sense at all because all you do is put that mattress up a little higher and suddenly more people will buy it. So initially it's height. The next section is someone goes to the mattress, let's say it's over here, and then they feel it. So they feel the mattress, okay, and they rub the fabric. So it's, oh, that's a nice feeling fabric. Which is great because once you've actually bought the bed, you're never going to touch that fabric again. So the second choice you make is basically to touch that fabric, doesn't matter at all. And the third thing you do, you go to the next bed and you go sit down and you bounce on it, okay? That's the third choice. Now, who on earth spends an awful lot of time on their bed bouncing up and down on the edge? Nobody. So the first 3 choices you have in selecting a mattress mean nothing at all to the quality of your sleep. So it's interesting how, although designers spend an awful lot of time thinking about what consumers want and what they need, often we as consumers aren't that intelligent in the choices we make. So it's up to the designer to think about, okay, so to kind of help the consumer make more intelligent choices. So, because I'm here up about materials, I thought I'd go through 5 different areas I think are going to be interesting in materials. And it's interesting, what's exciting to me is that over the course of today and listening to the presentations and also spending some time with researchers in the University of Philippines, you're already onto a number of these different areas. So I'm excited that you as a country and you as a sort of, have been able to sort of look at some of these challenges and are already moving forward with some of them. So we've got digital fabrication, localized resources, which I'll talk about a little bit about Philippine resources, biofabrication, stuff that you can actually make from bio-based resources. A new approach to waste, and we've seen that certainly in some of the pictures. And a last one I call circular everything. Okay, let's start with digital fabrication. So beyond just basic 3D printing, we all know that process now. There are methods now which are trying to take it beyond that. And I think this is a great example. You know how 3D printing works? It's basically just take a kind of toothpaste tube and you spray layers and then build it up. The challenge with that, of course, is you're relying upon the material to not fall over due to gravity. So soft materials are hard to do because what they want to do is they want to collapse. So this process, it's actually 3D printing, but instead of actually having just a plate, it's actually in a large vat of gel. So in the same way that, let's say, a glue works with a resin and a hardener, the resin is this big vat of gel, and then your hardener, you basically just spray into the surface. And what happens is you can spray and create objects such as that. So that flexible bag was 3D printed in a large vat. Simply by just spraying in the hardener, it connects with the resin and it basically hardens into basically a silicone-type material. You can also create seating for BMW, because then, of course, you can build these very flexible pouches that can work as pneumatics. So instead of having the basic, the idea of this is that digital fabrication started with things such as 3D printing, but we're now moving beyond that and now understand that it's possible to sort of do the 3D printing but in different ways to give you different structures which weren't possible before. Automating of manufacture of t-shirts and clothing. This one's a great example. It's basically simply changing the way that we manufacture clothing, because the suit I'm currently wearing, okay, this was made in the same way that a suit would have been made probably 300 or 400 years ago. Same with your clothing as well. We have highly technical industries. Clothing is not one of them. The fabrics, basically I've got a whole bunch of natural fabrics that have been around forever, and the construction, somebody sews it. So the construction method is antiquated. Whereas we're making phones using robots, we're basically making clothes with our hands. So this is a process which actually solves that problem by, instead of having a fabric which is flexible, it basically hardens the fabric using a resin, and then uses the material as a hardened fabric to take a robot and then sew it using a robot arm. So whereas previously a robot wouldn't be able to pick up a piece of fabric and sew it effectively, if you make it hard by putting a plastic in there, you can do it. And then what happens is afterwards, because the plastic is water soluble. Okay, I'm sorry. Is that better? Okay. Because the plastic is water soluble, you can then just simply rinse it away and then use the t-shirt. A shout out to Kevin and Unspun, who'll be presenting a little bit later. This to me is fascinating because it's not only creating a perfect fit of jean, but it's also changing the way that we construct fabrics. That his ability to basically create three-dimensional fabrics, as opposed to all other fabrics currently have been flat. You know, although this fabric goes over a body and basically has 3 dimensions, the material itself is flat. He's creating things which have 3 dimensions. Actually, the material itself has 3 dimensions. And then, of course, moving beyond the 3D printer, which is constrained within a box, we're now using robots to build things which are much larger. Here, it's basically creating a substructure for concrete. So enabling you to create larger format structures by strengthening it with a 3D printed structure. You can do that with chairs. You can also go a little bit larger and create entire large format structures just using the same process. This is built by a robot, simply just in the same way the 3D printer works. And then also, you can use robots and digital fabrication to build entire houses. This is an Australian company that is, basically, it fits in the back of a truck. The truck goes along to the place where you want to build a house. Then a robot arm comes out. It picks bricks from the truck, puts mortar on them, sticks them on the surface, and then basically just builds an entire house out of bricks in less than a day. So the idea of sort of 3D printing, we've moved beyond that now to construction, which can move in very much larger projects and almost limitless, because as long as you can basically get the bricks to that area and you can basically, the robot arm can reach it, you can build as big as you want to get. Okay, so localized resources. This is interesting to me because I'm at a location where almost 20 years ago, we looked at the Philippines to see what materials you had, and I basically created a list. Now, there are others apart from this, but it's interesting to me that you have resources, and it seems as though you're more effective than many other countries in actually taking those resources and doing something with them. I looked at some of these material types: abaca, piña, lahar, kwa, seagrass, and kapok, and so, okay, what are the people doing with them? You have an awful lot of these materials, sometimes more than any other country. What are people doing with them? Abaca, we've got non-wovens to be used in medical gowns. We've got the fibers used in 3D, in composites, in either tricycles or even in cars. Pineapple fibers, piña is actually now being used as a leather alternative. So these fibers can be added as part of a non-woven, added with a biopolymer, and then used as a leather. This one to me was fascinating as well, kapok. Kapok is basically, it's a fiber that's a third the weight of cotton. So think about your regular cotton t-shirt, making a t-shirt out of kapok, you'd reduce the weight by 60%. People are using it in fabrics, and they're blending it with cotton. They're also using it in insulation as well. So these are current commercially available products from kapok. So I'm not sure where they're getting the kapok from, but they should be getting it from the Philippines, because you have abundant sources for this, and this is a sort of material that you can then industrialize and then put out there in the market. My fourth one is biofabrication. Now, for me, this is a very important aspect because, actually, I'm going to go back one time, just because for the kapok. I was at the University of the Philippines. It was interesting because they're also, with the kapok material, they've realized that it's actually a great substrate for certain electronic components. So as well as basic things such as fibers for fabrics and insulation, these materials have much more high-tech applications as well. And it's locations like universities that are producing this work. The challenge you have at the moment, I think, and something that we're trying to actually solve, and I've had conversations with a number of people here to try and solve this, is how do you get the information about these materials out there to the world? You know, my job has always been to do that sort of thing, and we've worked with the Thai government to do the same sort of thing as well, where we get natural resources and we provide access to that information, use our online database. I want to do the same thing for the Philippine materials. So that basically, if people want to use these materials, they understand where to get them, how much they can get, what the performance is, what you can currently do with them. Because as a designer, but you never knew that you could basically use kapok for a range of different applications. So if you have access to that information, then that gives you the opportunity to be a lot more creative. So I find, what we need to be able to do is to take the information that's currently there and the resources that you have, put them on a database that is then accessible to a range of other people, and then allow them to create. Biofabrication, so making stuff out of renewable materials. Currently we make a whole bunch of stuff out of things that don't get renewed, whether it's steel or ceramic or current plastics. Biofabrication is understanding that there's an awful lot more to the natural world than we really understand. For many, many years, we were frightened of nature. Nature killed us. It basically killed us through bacteria, through fungi, through animals, that sort of thing. But now we're understanding there's an awful lot of potential value in nature. And even the ones that we used to be worried about, things such as bacteria. So some of the more recent developments are using methods of production that are involving things like bacteria, things like fungi, and things like algae. Whether it's paint created by bacteria. So this is actually a paint that's created by bacteria through the oddest process. Basically, this bacteria, what it does, it coalesces together in certain colonies, okay? So in one strain of the bacteria, it coalesces in a certain form, so it creates a green color. You can change its DNA, so then it coalesces in a different way, and then creates into a blue color. So by changing the DNA of the bacteria, you're able to create different colors. These colors can be added into plastics or into paints. So rather than having to dye things using chemicals, I can do it using bacteria. Leather from mushroom. Fungi grows very quickly. It grows with virtually no water. It can grow in the dark. So it's very effective material to produce when you don't have an awful lot of resources, especially if you don't have an awful lot of water. You can now, we've seen it used in insulation, as packaging material, but now even as leather. We've seen algae being used. Now, I know that currently there are concerns about algae being a toxic material, so why don't we just use it? These are two current commercial products that are being created using algae. One's actually a shoe, the other one's foam. But the good thing about this is that unlike some of the bioplastics and materials from renewable resources, there's no shortage of algae. And also, unlike things such as corn-based plastics, a lot of you have probably heard of corn-based plastics. The challenge with that, of course, is that it's using a food source. Currently, no one's using algae as food. And also, unlike corn, where it can only really be produced in certain areas, let's say the Midwest of the US, algae I can make anywhere. I can basically take a steel vat in the Arizona desert and manufacture it there. So I can produce large volumes of this bio-based material that can produce products from basically from a very simple source and manufacture it anywhere. We've also seen the use of DNA to change certain proteins in order to create things such as leather. Because a lot of our clients are worried about the use of animals in leather, so trying to find alternatives. So this is a good example of actually using DNA and simple proteins to produce that sort of material. And then, of course, spider silk. For a long while, it was basically the strongest bio-based material. Again, we're using DNA and sort of bio-based processes in order to create these materials. Because, of course, you can't really use spider silk. People have tried it, but it's really hard to milk a spider. And if you put a whole bunch of spiders together in the same way you do with like a silkworm, they basically eat each other. So you can't create real spider silk in large volumes. So what you have to do is you have to basically change an existing production of a material using spider DNA. So they put them into goats, they put them into silkworms, they put them into yeast, and it's a way of basically creating an alternative that has a lot of the properties of the spider silk without the need to actually use spiders. This one's actually from Adidas. It's one great advantage of this, though, is that they've also made it biodegradable. So with an enzyme, this at the end of its life will actually just simply biodegrade in water with the enzyme. And also, thinking about, so we think we know an awful lot about nature, and we know everything there is to know. Some Finnish researchers recently found out that cellulose, which is basically wood or pineapple fibers or a whole bunch of other fibers, is actually possible to create the world's strongest fiber. As long as you can process it correctly. This is stronger than carbon fiber, it's stronger than steel, it's even stronger than Kevlar. It's a bio-based source from cellulose. So I kind of feel that there's a whole area of untapped resources that we have from our natural materials. And that's kind of what gets me excited when I see research projects in the natural materials of a local resource. You don't really know enough about what the potential is for some of these materials that we're currently researching. Okay, so my next section is a new approach to waste. Okay, so it was actually exciting to see some of the pictures and some of the earlier presentations. You have a very different approach to waste than a lot of people in the US. For a lot of us in the US, we don't want to touch it. We don't want to get anywhere near it. Because we feel as though it's just, once it's basically it's been discarded, we want nothing to do with it. I think that's a very bad approach to it. Because if you think about it, the majority of product, just because I've decided to discard it, hasn't lost any of its value. It might have lost its value to me, but actually as a material, it hasn't lost any value at all. And some of the new approaches to waste is, okay, so this is a new product called gumshoe. Anyone guess what the actual shoe sole is made out of? Gum, basically. So it's a company that is picking up, or basically getting Londoners to discard their chewing gum into little containers. They pick up that gum, and they basically resynthesize it and make it into rubber. They've got a line of products which includes coffee cups. So again, it's basically understanding that just because we call it waste doesn't mean it has zero value. Same thing with a lot of construction waste. It's possible to take the old bricks and sheetrock and materials such as that and basically bring them together, mix them up, grind them down, and then recreate bricks out of them. So the new approach to waste is really, we almost want to remove the whole concept of waste. Yes, of course, there are certain things we shouldn't be touching. There are certain toxic wastes. But most of the products that we use, most of the stuff that we currently discard, hasn't lost any of that value. So to call it waste is really unfair. It's simply just waiting for another application. Okay. When it comes to recycling, the US and Europe, we kind of think we're okay with recycling. Problem is, for the last, I don't know how many years, we think we're good at recycling because we put stuff in the recycling bin, okay? We put it in the recycling bin and we think, okay, we're done. What we didn't realize was that most of the time, that stuff then just gets shipped to China. So all we've been doing is basically giving our crap to China. And at some point, China said, nope, we're not taking it anymore. We're not interested in that stuff. You're not going to basically give us all your trash. So now the US and Europe has a problem because whereas it used to claim it had very high recycling rates, it now basically has to deal with its own recycling. And you can see a couple of the quotes at the bottom there. Basically, whereas before they used to get paid for the stuff, they now have to pay to get rid of it. So what's happening in the US and Europe is this understanding, and almost in the way that you have now, which is that you have to do something with that waste. You've got a whole huge waste problem, we do too, but now we have to deal with it ourselves. And what I'm hoping is that as a result, and as I've seen in the presentations earlier today, you're dealing with it. We need to deal with ours. And my hope is that over the next few years, we'll start to see some innovators in the way that you're innovating, using those materials. So instead of now basically landfilling it, which is what we do at the moment, so it's a bit embarrassing. Basically, in New York City, you put all your stuff into a recycling bin. It doesn't go to any recycling, it goes straight to the landfill. So even though we keep on doing this process of putting it in, it doesn't go anywhere. It simply just goes to the landfill. So we're trying to find people who are interested in reusing those materials, because they have value. They have an awful lot of value. We just need to find a way of using them. We are getting better. This is post-consumer recycled nylon into high-quality shirts. Stella McCartney is now actually using a process called garment-to-garment recycling. Now, this is where I can take my old T-shirt. I mean, I've done with my T-shirt. I put it into one end of the machine. It goes through. It basically gets ground up into smaller fibers. Those fibers then get respun into a yarn, and the yarn gets knitted into a sock. So a T-shirt becomes a sock, which is a wonderful way of basically retaining the value of that material. Stella McCartney started to do it as another brand using them as well. So we're getting better at the ability to maintain the value of the products that we are getting rid of. Because we're not really getting rid of them, they're simply just applying them in another application. Same thing with a lot of our packaging waste. Now, one of the big challenges with modern packaging is because we as consumers demand things to last longer, we also want to make sure they taste great, they don't smell out of the packaging. So what happens is most of this packaging, it is now a multi-layer. So your packaging typically is between 3 and 8 layers of material. So let's say I've got an outer layer that I print onto. I've then got a secondary layer which is structural. Then I've got a layer which makes sure that none of the odor gets out. I've then got a layer which makes sure make sure that the material doesn't get affected by ultraviolet light. So multiple layers. So what do I do with that now? Instead of having a single material, which I could maybe easily recycle, such as this, I mean, I could basically put this in a recycling bin, and it's majority just one material. Packaging, it's a whole bunch of materials. So typically we have challenges with that. So what they've now realized is that you can actually just grind the whole stuff up and make products out of it and use the little flecks of aluminum that are part of the packaging as a design aesthetic. So rather than trying to pull everything apart, just grind it all up, manufacture it into actual viable products. Ocean plastics. Okay, a lot of our clients are interested and concerned about the plastics in the ocean. We've done a fair amount of research about this and understand a little bit more about what's in there and what are the alternatives we could use. Okay, so of the 10,000 different plastics out there at the moment that you could use, these are the only 3 that will actually dissolve in the ocean. It's 3. And most of them you probably wouldn't even use anyway. Rayon is it's basically just a cellulose-based fabric. So a t-shirt made out of rayon or tencel will dissolve in the ocean. Cellophane, which is a transparent wrap used to cover food, that dissolves, and PHA, PHB is actually a relatively just commercially available plastic. Those are the only 3 things that will actually dissolve in the ocean. Everything else will stay there. So if you're looking for alternative materials that are ocean safe or are biodegradable in the ocean, this is what you got. That's it. And it isn't really much. So what we really need to do is to remove all of the potential plastic materials, because it's not as though we've got a simple alternative to the current materials we use. There really aren't any viable plastics that will not last in the ocean for a long time. Okay, so what's in there? Okay, if you saw the earlier image, it was a whole bunch of bottles and that sort of thing. But the majority of the plastic is actually this. It's nets. And that's kind of a good thing, okay? It's because if you want to get rid of a net, if you want to basically remove a net from the ocean, you basically grab one end and you pull. And the whole net comes with you. And maybe you've got 40 pounds of plastic in that one net. So one action, pulling the net, basically removes 40 pounds of plastic, okay? That's a relatively efficient process. If you try to do the same thing with a plastic bottle, okay, so if I go in, I grab one plastic bottle, I've got maybe an ounce of plastic, so I have to do that now 3,000 times before I get the same amount of material I got from just the net. So the challenge with actually trying to remove plastics from the ocean has always been, with nets it's okay, with every other plastic it's just not worth it. If you could try and basically take a big trawler and remove it all with a net, problem is you get a whole bunch of marine life in there as well, and that's not particularly good. So we don't yet have a viable solution, but if you're going to use ocean plastics, use nylon, because nylon is one that's basically, it's viable, there's a fair amount of it, and also you're removing a huge amount every time you basically pull it out of the ocean. You can also recycle it into viable materials. These colors come from those nets. So the recycling process, one of the challenges of the recycling process, and one I'm sure a lot of you had when you're trying to basically produce products out of recycled materials, is when you mechanically grind it up, the colors all get mixed together and ends up as sort of gray or green or brown. If you chemically recycle it, you can get all sorts of colors, because in chemical recycling, what happens is you can basically pull everything apart, you can remove the colors, you end up with transparent. So there are ways in which you can take recycled material and end up with a really high quality, wonderfully colored material. So don't think that just because you're going to be using recycled material, it's going to look dirty brown and dirty gray. There are viable ways in which you can recycle, but you can get some really beautiful colors from it. This image is also interesting because you know I mentioned about the problem with basically removing plastics from the ocean. It's a very time-consuming and energy inefficient process. Well, maybe we should just try and stop the plastics getting to the ocean in the first place. So what these red regions are what they call ocean-bound plastic regions. So rather than wait until the plastic gets into the ocean and pulling it from there, why not stop it before it gets to the ocean? So these are all regions where a company called where a company is actually helping the population to actually collect the plastics before they get anywhere near the ocean. And you notice it's basically areas where you've got an awful lot of coast. So this is actually a better alternative. So you can actually source rather than ocean plastics, which you can typically only get nylon. Now if you're using ocean-bound plastic, you've got a much wider range of materials. So it's things such as polyester and polypropylene and polyethylene, all plastics which you can use in a wide range of applications because they're ocean-bound rather than already in the ocean. Okay. My last one, and this one's sort of a conversation with the designers themselves. It's about circular everything. You've probably all heard of the circular economy. If you haven't, it's a very simple process. What you do, rather than the original idea of you take something out of the ground, you process it, you manufacture it into a product, you use the product, and then you throw the product away, which is a very linear process. This one understands that if in order to reclaim the waste, or get rid of the idea of waste altogether, you need to create a much more circular process. So rather than taking material out of the ground, let's take it basically from a recycling stream. Rather than throwing something away, let's basically offer it as an alternative as a recycled material. The difference is, though, and the challenge with this, of course, is that design becomes an essential part of this entire process. Because without design, a product is, okay, so I'm going to take this clicker, okay? This clicker at the moment, if I try to recycle this, I'd have a very hard time because it's been designed not for an end of life. It's basically been designed to perform as it's supposed to, but with no thought about what happens when this no longer works. I throw it in the trash, that's typically the way. Circular economy says, what else can it be used for? If we're stopping to think of things in terms of waste, then this has a potential second life, third life, fourth life. So so then if that's the case, I need to design this with a potential to get disassembled, to be reused, to think already about what its second life is going to be. What can I use these plastics for as an alternative? So let's say, okay, I've got a clicker. You know what? Let me make plastics now. Make sure that the plastic is suitable then to be used as an iPhone case. So then I make sure that, so I make it easily pull apart, so I can pull it apart, and then the plastic can be ground down and then potentially used as an iPhone case. Already think about the second life. Already think about what else it might be able to use for. And that, of course, is going to be a new challenge for designers, because up until now, you've thought about sustainability in terms of what materials can I use? Can I use recycled materials? How do I design? And then basically that was it. Now you have to think about, okay, well, how do I design with the potential for a second life, third life? That becomes a lot more complex, and it also means you need to understand the manufacturing processes a lot more as well, and also the way that you recycle. So unfortunately, it is your challenge now to learn, instead of just about design, now about the manufacturing process, where the material comes from, also what happens in the recycling stream. Assuming that we can recycle, I mean, do you know what happens to your coffee cup? Do you know what happens to the lid of your coffee cup? Do you know actually what happens to it at the end of its life? You know it should be recycled, but do you know how it happens? Because if you don't, then you don't know how to design best in order to make sure that that coffee cup and that coffee lid will get reused again. So this is just basically the three main points I think of. So as a designer, if you don't know where your material comes from, then shame on you. Because I think you need to understand, if you're going to design, you need to know exactly where that material came from. Because without it, you're not going to understand where it could then go afterwards. So if you're going to design, I think it will be reprehensible not to know any time you design where the material comes from that you're going to design with. You need that understanding, you need that knowledge. You need to always consider that it's going to have a second life. Don't ever think this is just going to be thrown out. Because then again, you're missing out on the opportunity to move towards the circular economy. And also, we always talk about end of life. I want to get rid of that entire concept. Because end of life suggests that at the end of this life, it's dead. No. You know, if I made one clear point in this, is that basically we need to stop thinking about waste as waste. We can clean materials, we can reuse them, there are plenty of resources that will enable us to rethink what I can use this material for afterwards. So if it's basically, if anything, I want to end this with, it's basically, when you design, I know you're interested about making something beautiful and purposeful and usable. I also want you to add on to that. I want you to become, not material scientists, but at least people who understand the materials, where they came from, and where they can go afterwards. Because I think as a fulfilled designer, as a designer who can be creative but also satisfied with the work that you have done, you now need to consider that entire circle. Thank you.
Thank you, Dr. Dent.